probably this is the spot. So welcome everyone, and for those of joining online, and welcome to the City-REDI external seminar this week. And we have Dr. Kevin Connolly and from University of Strathclyde, and he's a Chancellor Fellow at the university. And his main research interest is in input-output, CG modeling, and environmental accounting. And he has published in leading journals, including regional studies and economic system research. So welcome, and floor is all yours. So Kevin, would you do you prefer to take the questions a long way, or would you prefer to the
easier just if we just take questions as we go?
Yeah,
I think that may be the easiest way. Is it a clicker, or is it just?
Yes, hopefully you have 45 minutes for the talk and 15 minutes for Q&A. Thank you.
Yeah, is it a clicker, or is it just use the? Is it just use? Yeah, just make sure. Yeah, so thanks for the introduction, and thanks for inviting me to present some of the work that we focus on at Strathclyde or in the economics department. And as Hanjia said, my background isn't actually in economics. I was an engineer for all my sins back in the day, and I kind of moved into using input-output models, not just to look at environmental purposes. That's kind of my main research area, but also look at social policy issues as well through CG and some fiscal issues, which is very important for Scotland at the moment, as you'd expect. I will try and talk as slow as possible, because I know I get quite deep Scottish accent, so if you don't understand me, just give me a shout or shout at me. I won't be offended. But so kind of the background of this work was like last year, you had COP26, what was in Glasgow, so we thought this is probably an interesting topic. We should say, well, why are emissions very important, or why should we look at emissions, and can we look at emissions? So I'll kind of get into some background, but that's kind of where this project came from, kind of stemmed from this idea. Well, COP26 is here. I think everyone in Glasgow was doing something to do with the environment, so we thought we'll just jump in the bandwagon. So I think my working paper has been given out, so it should be nearly there, and we're hoping that we submit this research in the next few months, during the summer at least. And this is done with my colleagues Grant Allen and Edith Moira. They're both based at Strathclyde as well. So a quick introduction of outline of what I will talk to you about for the next 40-45 minutes. Well, first of all, it's key to any research question you're doing is why we're actually doing it. Why do we want to look at city level emissions? And what is important here, or we feel is very important here, is this policy aspect of the research. So it's not a solely academic point of view. We want to see, well, how can policymakers maybe take our research and advance it or use it at least? And we'll see why city level emission is kind of a key issue here. We'll also look at, well, how are city levels emissions measured? And it can be quite a complicated issue. As you'd expect, it's difficult enough to measure the UK emissions. We have different components. So if you're going to a city level, where there may be less money, less detail, less information available, it can be even harder. So this is what we thought, well, when we first started this, we thought, well, we have a question, why city level emissions, how we measure it currently, and thought, well, we hopefully have some expertise in multi-sectoral modelling. We thought, well, how can our research expertise, how can we maybe help to answer some of these questions that we found are difficult to find? And I know City-REDI, I know people here, they might not be very familiar with the idea of multi-sectoral modelling. So I thought I'll give some background into the method and what exactly we've done, and why. Well, just some initial results for Glasgow as a case study. So yes, we focus in Glasgow here, but the main points we take away here is more for the regional city policymakers and how maybe they take their results and then they can apply them to their city, etc. So the first, or the biggest question is why city level emissions? Why did we focus on emissions coming out of city? Well, as you probably already know there is increased urbanisation across the globe. And this is see increased globalisation both in developing and developed countries, and maybe not happening at the same rate as developed countries, but it's happening. So we looked at the rate, well, it was the rate of statistics when we started this, and in 2015, about 25 gigatons of CO2 equivalent was attributed to cities. So cities accounted for around about 62% of global emissions, and that was in 2015. In 2020, depending what we expected, that was to increase to 67%. So that's a 5 percentage point increase in the proportion of global emissions attributed to cities. Of course, this might say emissions might go down in cities, might have less emissions per person in cities, but this is driven by increased urbanisation. It is driven basically in cities, it will mostly be the need for heating, so domestic housing, etc., or if depending where you are, domestic cooling and electricity. You may also have some, depending on where the city is, what the makeup of the city is, you may ever have some large manufacturing, some industries. So the cities also include industrial emissions. Because we're economists and well, environmental economists, we thought, well, why is this important for? Why is this urbanisation important, both from an economic and environmental point of view? Well, people move to cities because they feel they get better economic opportunities. So that's why they move to cities, but then that's increased city emissions, or you'd expect this. And by the next century, there is some projections that 80% of total global emissions could come from cities. So you can see it. The proportion of emissions attributed to cities is ever increasing, and this isn't expected to slow down anytime soon. Also, one of the biggest issues as well is this idea that cities or smaller regions as well are seen as energy sinks than energy resources, which rely heavily on resources from outside of their boundaries. Again, because we thought, well, maybe use Glasgow as a good example. So if we look at Glasgow, and probably the same in Birmingham, I forgot to check, but Glasgow has no large-scale electricity generation within its city boundaries. It has maybe some small-scale solar, and as we were just talking about 5 minutes ago, and maybe not that much sun in Glasgow, so electricity generation is very small. So you're relying on imports from the rest of Scotland, the rest of the UK. Same with natural resources, materials, etc. There's not much in these cities, and it'll be the same worldwide. Well, mostly the same worldwide. So these are seen as energy sinks, energy resources. So they said, well, this may impact emissions or will impact emissions. And this kind of harkens back to the idea that how cities are very interconnected, and cities are connected to both a region, the region and the nations and the rest of the world. So, for example, as we'd probably expect, cities don't have much natural resources, so they rely heavily on imports, and that's from different areas, different regions, and also export. But what is quite interesting as well is these cities is this fact of you have different levels of government. So these are all interconnected, but they may not have the same goals. So we coming from Glasgow, we get basically three governments, three government policies, but maybe not interacted together. So you've got the Glasgow City Council, you've got the Scottish Government, and you've got the UK Government. And it depends what are these goals for these cities, or is it more economic goals, is it environmental goals? So you may have some friction here. Also, you have households. There's many people that don't stay in the Glasgow area, but they'll move or they'll stay in the travel to work area, and they'll travel into Glasgow from the surrounding region. So you see that this idea that cities are interconnected, and it won't just be the emissions or the emissions happening within the city. We'll have different emissions throughout the different regions, and it depending on what products we're consuming in these cities, etc. And measuring city emissions is becoming increasingly important, and we'll talk about why this is the case. So we have this idea that we do have national emission metrics, and these are quite easily based on political territorial boundaries. So if we're just saying we have a city, we have a nation, so we have the UK, we don't know the UK's boundaries, it's quite easy to define these, and especially if the UK is an island, it might be easier to identify what's coming in, what's getting exported, etc., and attribute to some emissions to this. But if we move towards cities where, again, we said that the energy sinks, they're relying heavily on imported goods, we may need to look at other metrics. We may need to take into account the embodied carbon of the, say we have a can of Coke, we need to take the embodied carbon of this can of Coke because it's been imported, and we are relying heavily on imported goods and services. So it's not this idea of what we're producing, it's what we're consuming. And in the literature, this is kind of what we're moving to as well. And this is kind of the second point, just reinforces this, the idea that as we move to more urbanisation, there's a greater likelihood that imports to economic processes are imported. So it's leading to a very important question about where do we draw the boundaries around emissions, so with not just production, but also consumption. And recently, there has been many organisations that said, well, we need to look at this in more detail, and we need to showcase some practices and how we can develop emission accounting and at a subnational level, which include cities. Also, we felt, not just from an environmental point of view, but basically policy in general is moving more to regional policy. And I think as City-REDI will see this, so we have the levelling up agenda, etc. More emphasis has been put on regional policymakers to make change, and or policies more focused on a smaller scale. So again, it's important for policymakers, and we just don't want this to be an academic exercise. We want it to be an exercise that maybe can introduce some change or help people, help the cities, councils, etc. realise their emissions and what maybe they can do about it. So because it is a very important issue, environmental issues are one of the most important impacts going to impact society in the next 20, 30 years, there is quite a large literature out there to measure emissions at a subnational scale, and these use, there is a range of different methodologies, but we kind of split these up into two main approaches, and there will be trade-offs between these two approaches, and we can get into these trade-offs. But the first approach we can maybe take to measure emissions is this idea that we can use and gather primary data to get estimates on regional carbon emissions. So the region here might not just, some of the literature does go to city, maybe a city, a high tier one region, or you could go to neighbourhoods. This is where you're going out, you're gathering your data. This might be not just an economic exercise, it could be an engineering exercise, bring in a multidisciplinary team, and you can maybe estimate the carbon emissions of, say, a certain area, scale that up. And this, as you'd expect, this is a bottom-up approach because you're gathering data and you're getting your estimates. But this idea is that you'd expect this to be more accurate than some of the other methods, or the top-down method we talked about, but it does come at significant cost. If you're gathering primary data on emissions, etc., it does come at cost. You need to employ these machines, these technologies, and also pay wages. And as well, it becomes, if you want to do this for more than 1 year, it's a continuous assessment, again, increasing the cost. And if you're looking at a city level, this might just not be cost effective. It might be quite difficult to do. So you have this other kind of approach, what is known as top down, where you scale some national data. So there's quite good national data on emissions, as you'd expect, and you use sector information, maybe population, car use, etc., and you try and estimate what is emissions at a subnational level. And as you expect, this is less costly. It's a wee bit easier to do. There's not much expertise, but it's also less accurate. So really depending what you want to measure and your cost effectiveness and your accuracy. Also, we need to look at, I've kind of pointed to this previously, we need to know, especially for subnational, what do we want to measure and what should our policy as a regional policymaker be focused on? Should it be on the emissions we produce, or so that's known as scope 1 emissions, or maybe what are we going to consume, or what are we consuming? So that's your consumption emissions, and these are known, depending on what you're measuring, can be scope 2 or scope 3 emissions. Because cities are energy sinks, we need to go, well, we don't need to, but it would be ideal if we knew our consumption-based emissions, and this is where we feel multi-sector modelling can come in and help with this idea. So just for the UK does publish its national emissions in line with international agreements. So if you look at the greenhouse gas inventory for the UK, you can get greenhouse gas inventory for a lot of different industries, and I've like quite broken down the different actual pollutants, etc. And there is, so that's using the greenhouse gas inventory, and many countries worldwide have this, and they use similar methods. But there's also the ONS does publish emission metrics at local authority level. So you could get it for Birmingham, you get it for Glasgow, and they use a Bayes methodology, where these take the national emissions and they scale them by end use measurements. So that's the kind of your top-down method. You're looking at some of the information from a local area and you're scaling the national emissions down. So for example, if you're looking at it in a geographical area, we can look at, there is consumption-based estimates on what is a household consuming per square metre of land, etc. And also what is the transport use. You get miles travelled, so if you have the amount of miles travelled per local authority area, you can kind of scale down the national estimates. But there is, as you'd expect, it's not the most accurate. There's some, so we found for this paper, we found there was two main issues with this measurement, if we're looking at a sub-national level. The first of these is that the subnational accounts do not take account of the location of emissions for electricity consumption, and this is really important, and this is kind of the idea we focus on this paper. Just for example, so we've got Glasgow, which is based in Scotland. Scotland has a net zero electricity electricity grid at the moment, so we produce more green electricity than we actually use. But when you look at these regional, subnational, local authority measurements, they're just scaling the UK measurement based on the UK's electricity emissions coefficient. So we said, well, that from being the local area, that maybe doesn't make sense, and it's maybe overestimating what Glasgow emissions are at the moment. And if we're overestimating what the emissions are at the moment, how is policymakers meant to introduce policies that can alleviate this? So this is showing that there's an issue here, and we need to start thinking about it. We need to take into account some local expertise as well. There may be several different industries, etc., in different cities. So with different industrial makeup in Birmingham as in Glasgow, again, this maybe just isn't taking into account what we do at the moment. And as well, they're not totally aligned to this idea of production or consumption based. It's kind of a mixed match of both. So we thought, well, can we use our expertise in multi-sector modelling and maybe adjust this, or help, maybe not adjust it and give a direct answer, but maybe just inform policymakers a bit more to say, we need to extend this analysis. We just can't base our consumption on national metrics and then get measurements from that. So again, we use multi-sector modelling. But why Glasgow? Well, first of all, I'm from Glasgow, so I know the area, and it makes it a bit easier, but Glasgow has a commitment. How realistic this commitment is, it can be debated, and I debate it near enough all the time with the council. But Glasgow say by 2030, so less than 7 years time, they say they want to be net zero carbon. And if you've ever been to Glasgow, there's a lot of old tenement buildings we need to be basically not knocked down, but a lot of work being done to make them energy efficient. Cost billions of pounds. So I don't know what Glasgow City Council is getting billions of pounds in the next 7 years, but this is what they said, and I don't know if they'll be pushed for this. They've done this because it was came up for costs. They said we need to be seen as green. They do have some policies in place, such as active transport, etc., that maybe can reduce emissions to some point, but they have this goal I'm not, if you can't tell, I'm not very optimistic, but have a go. So that's why we thought, well, we're from Glasgow, we have local knowledge, but there's also a policy context of why we're doing this research. And so we focused, well, we said to have this chat, what does interconnect this? So instead of just focusing in Glasgow, we thought, well, maybe we extend this to the Glasgow city region. So there's different city regions within the UK. Glasgow was established in 2014 by the UK Scottish Government, and it's basically these these 8 local authorities in dark blue. So we have Glasgow, South Lanarkshire, North Lanarkshire, Inverclyde, etc. So it's 8 local authorities. It's the 4th largest UK city region, and it's a population of about 1.8 billion. So it's about a third of the population of Scotland, and it has around 30% of Scottish GVA jobs. So it's quite a large economic area. And when it was first introduced, the focus was on, as you'd expect, if it's an economic region, it's on infrastructure. How can we improve infrastructure? Improve infrastructure should maybe help, but also environment, some life sciences, business support, and also key, as many city regions are, is tackling unemployment. So that's just what it is. But if you look at the challenge for the Glasgow city region, is this is historic emissions and should be a net zero trajectory. So in 2005, between 2005 and 2007, you see emissions is stable around about 4 megatons of CO2 equivalent per year. You have a financial crash, and what many economists say is what's the best thing for the environment. You get a recession, reduce negative output, so there's just environment. It's not good for the economy, it's good for the environment. You can see this happens because in Glasgow we get a reduction in emissions. It kind of recovers, and then from about 2014, the emissions you see there's start to be a substantial drop to 2019. So between 2005, 2019, there's about a drop of about half the emissions. And many people would say that this might be the easy wins. This is your industry leaving, etc. But now, if Glasgow says they want to be net zero by 2030, we're basically double our emission reduction from the last 15 years, and it's going to be a lot harder. And as well, as if you're used, so this is based on the base numbers, is this actually Glasgow's emissions? Is Glasgow's emission higher on this, lower on this? So what are we trying to fight if we don't know what our actual emissions are? So that's the questions, at least the questions we try to answer. So again, we used multi-sector modelling, and we thought, well, what can multi-sector modelling contribute, or what can you bring to the table? Well, you have with modelling, multi-sector modelling, you have an organisation of emissions alongside data, and we feel this is really important. We've seen in the previous graph how the environment is linked to the economy. If the economy goes, maybe it's bad for emissions, or the opposite. But if you work with more green, etc., this can change. But there is a large literature out there about looking at emissions, different types of emissions, and there is a quite large literature which is really important, is this idea of emissions embodied in trade. And if we are exporting and importing more, what is happening here, and where's the footprint happening exactly? Also, there's a literature based both on the consumption-based emission footprints and the territorial or production-based carbon footprint. So again, we try to take all 3 of these different components in our analysis and use the techniques seen in these papers and apply them for Glasgow, but then we try to maybe adapt it and ask some questions taking into account local knowledge. And recently, there has been quite significant methodological developments in extending single and multi-regional city footprints to look at smaller regions, so city footprints. And again, I keep on going back to this, but we want this to be taken seriously by policymakers. And coming from Glasgow, coming from Scotland, there's quite in local government. There's a lot of people who's worked with input before, so they know the techniques and are quite familiar with it. So again, we're saying if we're taking something that's familiar to policymakers, maybe they take it on board and make it useful. Maybe see why we can use it. So I know many well, some of you might not have came across multi-sector modelling before. So this is just a diagram, a figure of what a simple single region input-output table would contain. So we have these different industries. So these are maybe agriculture, manufacturing, etc. So this is a groups of businesses that kind of do the same economic activity. And within, you can see that, didn't know if you see that. So within this upper left-hand quadrant, this is your intermediate inputs. This is basically your sales from these different industries to other industries for what they'll use as inputs to their industrial processes. So if we read across the rows, we can see that industry 1, in fact, you're reading across the rows, that's your sales. So industry 1 will sell to industry 1, 2, 3, all the way up to X, and they'll use that as industrial inputs. But industries are businesses just don't sell to other businesses. They also sell to consumers and also export some of the output, some of the goods and services. So these are also contained within the input-output tables, and this is what you're known as final demand. So industry 1 as well selling to other industries. They will sell to households, other domestic, government, etc., and they will export some of their goods and services. So you can get total output as a combination of your intermediate sales plus your final demand sales. So that's across the rows. But if we read down the columns, this is the inputs industries use to develop their goods or service. And so again, if you just look for industry 1, reading down the columns, industry 1 will take inputs from other businesses within the same industrial classification. So it'll have its own industry sales, and then it will take maybe take some inputs from industry 2, 3 up to industry X. So just for example, in the Scottish input-output tables, there is 96 industries identified. So you can get the sales and purchases from each of these 96 sectors, and this kind of gives you a snapshot for that particular year of what was happening in the economy. You can use this to model, etc., or do some linkage analysis, which we can look at emissions as well. Indices just don't buy from other industries. They'll need to import from the rest of the world, the rest of the UK, need to pay tax, which is quite important, and maybe have some, as well, we'll have labour costs, capital costs, you'll get inputs. So that's just a basic design. It's just a simple design, because I know maybe some of these haven't came across input-output table before, but this is just your basic design. So these IO accounts have been used extensively in the literature for 40, 50 years to capture the link between economic activity and environmental impact, because we know that each of these indices will use certain materials, will use certain electricity, will use certain heat, etc. So we can type out an emission coefficient for each of these industries. And the IO account, so what the diagram just previously showed you, is basically it shows interdependencies between different sectors of the economy. So for example, we know how much, so in the Scottish table, we know how much whisky or alcohol, maybe the service sector accommodation buys in a monthly value. So we get an idea of what is linkage. If maybe there was increased demand for accommodation or food and beverage services, you expect that to follow through with an increase in demand for the alcohol beverage sector. So basically, if you look across each of these rows, it's basically a list of simultaneous equations. We can get output of each sector I as a combination of this ZI. So it's a matrix of, it's a list of inputs. So Z is basically inputs from I from sector J. So that's your intermediate information plus your combination of final demand, your FI. So that's your final demand to households, government, exports, etc. So that's just basically putting that information into a simple equation. Through it, in addition, just this idea of technical coefficients that is expressed in inputs from sector I to the gross inputs of sector J. So it's basically input coefficients. We can go through some mathematical representation and get this idea of a matrix of output X is equal to this I minus A inverse matrix times a vector F. I didn't want to get into too much detail because this isn't a multi-sector modelling class. This is the basic idea. If you increase your final demand, you'll get an increase in output, and we can use this. And so we can say, well, say there's a policy where we introduced a change in final demand for a certain sector. We can see how this flows in the economy. But that's the simple part of it, or not a simple part of it, a simple explanation. I can give you more detail, but I don't want to bore you. But so we want to extend it, or how can it be extended for environmental impacts? So simple reason here, we can get emission coefficients, you get from ONS, etc., and we can attribute these to these different sectors in the economy. So we get emission coefficients, so emissions per unit of output for each sector. We apply this to our output sector. We can identify the emissions from two perspectives. So first of all, we can get the emissions related to the total output for each sector. So that's the first equation. But maybe more importantly, we can look at, well, what is the emissions embodied with the consumption of the goods? Because we know the linkages within these input-output tables. These all have emission coefficients. So we can add to this previous equation I showed you with the delta F, the log TFF, we can add emissions matrices, etc. to this. As long as we have the information of what the emissions output from each sector is, we can try and estimate what is
Just clarify that then. So you just, in any given sector, you did the 93, you're just assuming that every bit of output it represents the same emission. You're just taking an average
for each sector.
Yeah.
Yeah.
So in the example you gave about difficult houses to make energy efficient, you know, some are very energy efficient, modern houses, other the time are very difficult to.
Yeah, so that important issue here is it depends what specific issue you're looking at. So I said there's 96 sectors, but if you'll get the information, what we have done previously is you can disaggregate these sectors if they are, you see, very important. So an example of this is in a previous paper. We looked at, so there's one agriculture sector, but we were specifically interested in beef use, because beef use is a lot higher emission coefficient. So we separated the sales and purchases for the beef. We used information, we used different surveys. So you can extend it. If you have the data, you extend it to your need. But I was just talking about the base tables here. The base tables is, you can use it, but usually you need to disaggregate as well. If you're doing households, you can disaggregate it into different types of households. It's common to look at, well, not common, but we've looked at households by quintile, because you have different consumption. Lower income households spend a lot more than energy, etc. So we look at that, especially coming from social policy. So I should put that caveat, that's the base sort of tables, but you adapt them to your need. Yeah. So you get the emissions, so this is a single region input out environmental analysis, and there is a lot of literature here. There is one major issue, is this is only production-based emissions. This might not be the most relevant sort of methodology for a city, because it would only be what was your emissions related to the goods and services you bought within the city. Not really that important, we said it's an energy sink. So there is this idea of, it's becoming more common as we have more data, as it's been seen, we can move this idea of multi-regional analysis. So instead of just looking at what is the sales and purchases from an individual region, we can extend this and look at, we have these export columns, if where exactly we exporting, where exactly we importing, and what sectors. So this is the idea we've moved to a multi-regional MRIO framework, and as I mentioned, MRIO application environmental purposes have been increasingly common, and some people are moving towards going extending past emissions, but maybe land use, etc., energy, climate, food systems. But for our purpose, we want to look at emissions, and because you're looking at a city, we want to say, well, how can we look at these MRIO, and how can we look at first city level emissions? But fundamentally, the structure of a multi-regional input-output table is kind of the same as a single region. It's just been extended, and I'll get into that in the next slide. And for the data, there's a range of multi-regional input databases which do exist, but these must be used with caution because it's quite difficult to get the data. So a lot of these multi-regional input databases are based in national statistics. That's quite easy to estimate because we know the UK is maybe exporting to France, etc. But when we move to the sub-national, it gets really difficult. How do we know? And we're finding this. We've got other projects with. If we are looking at trade, we don't even know Scotland trades with England by sector. Well, very well. So it becomes increasingly difficult. But we can try and use these sort of techniques or estimates of what we can use. So we must be taking caution. And this is just your idea of the MRIO, or just how it's extended past a single region. And this idea that for this, we've looked at a city, so this is a 3-region model, where we have the city, rest of the nation, rest of the world, and this is the basic structure we use. So we'll have Glasgow, rest of the UK, rest of the world. You can see the intermediate quadrant has actually been increased. So you have the sales from Glasgow to Glasgow, rest UK, and Glasgow to the rest of the world, and this is done by individual sector. So again, it's just extending these interdependencies, and you get an idea of what's happening in emissions. So that's just a kind of a figure of what these analysts are. But what we actually do, what we've done in this paper, is we built an input-output table for Glasgow, for the Glasgow City region. It wasn't actually built for this project, but we built it for a separate project. We had the table. We said, well, why don't we use it? So what we do is, so the WID, so World Input Output Database, has 43 countries, well, 43 regions within it. It contains information on what they buy and sell, or the interdependencies. So we basically extend this by one region. So we take a purposely built Glasgow City region input table and separate the UK using this. So we now have a Glasgow City region table and the rest of the UK table. And we have a full map of the production and the consumption in Glasgow City region, as well as its trading with other regions across the world. And the next slide kind of shows you where we got the data. So basically what we've done is we've extended the WID database to 44 regions, which mostly contains the largest economies with decent national account data, and there are also many smaller regions, nations, what are aggregated up to the rest of the world region. And there's 56 economic sectors, so it's a bit smaller than the UK table. So initially in this exercise, we just use the standard. So we've seen in the literature, there's standard methodologies that we can use. So we take our initial standard MRIO analysis to calculate aerial carbon footprints, personal carbon footprints, as well as a production-based emissions for the Glasgow City region within the global system. So the production-based emissions kind of talks itself. That's the emissions produced in Glasgow. Both aerial carbon footprints and the personal carbon footprints are consumption-based metrics. It's just as a slight difference. So the aerial carbon footprint is that's a full consumption emissions within the region, or a full consumption-based metric, whereas personal carbon footprint, you don't need to take into account tourism within Glasgow City region. You don't take into account government consumption and investment. So it's just a different metric in the literature. But if you have to think of overall consumption-based metric out this area wider, we just added personal carbon footprint to make sure the results kind of made sense. So this is basically what we've done in the paper, or how we used a Glasgow City region table and extended the WIU database, and that shows you the data we used and how it proportions maybe some inputs and final demands. So again, this is in the paper. I've just read it 5 minutes left, so I better get to some results. So here is the multi-regional MRIO carbon account for Glasgow City region, and it's kind of, you get the results you can expect. So you have a production-based measurement, and you have this aerial and carbon aerial and personal carbon footprint measurement as well. So we mentioned energy. Glasgow, you'd expect, is an energy sink, an energy source, and this is shown here because consumption-based metric is higher than production-based metrics, and as you'd expect, you have the personal carbon footprint is lower than the aerial carbon footprint because you're discounting government investment in tourism, etc. So that's, if you've seen the literature about very well rehearsed in the literature of this sort of technique, this isn't going to be anything new for you. You're not using a brand new technique, etc. You will also get weather emissions attribution by country. So as you'd expect, Glasgow very interconnected with the rest of the UK, and so that's that GBR here. And also you expect it has kind of high links with China, the consumption of goods, etc., US and the rest of the world. So these techniques, this has been done in papers before, so this isn't our contribution. Our contribution here is we know that these results are going to be off because we have used an emissions coefficient related to the rest, to the UK in general. We know that basically Glasgow's electricity generation doesn't act as a generation sector, acts as a more service sector. So most of the employment in electricity in Glasgow, the Glasgow City region, is services, it's head office, SSE, etc. So this is where we say, well, what happens if we vary these emission coefficients and we just extend the literature a bit? What happens to these results? So we are in our modelling, we extended the emission coefficients and had 4 different simulations. Well, I'll just focus in the first 2, so that still needs change. But the first coefficient, this is kind of your stick WI database, and this is what is done in the literature at the moment. Where if you take a region or you take a city, you're assuming the emissions coefficient is the same as the national coefficient, so the rest of the UK. So emission coefficient for the UK is equal to that for the Glasgow City region, is equal to that for the rest of the UK. But again, for this point 2, is this idea that we know that the electricity sector in the Glasgow City region doesn't really act like this. So we adapt the emission coefficient to say, well, Glasgow is based at a service sector, so we take the average of the service sectors we see in the WID, take the average emission coefficient and apply it to this electricity sector. And why we do this is because this begins to capture the properties of the Glasgow City region electricity sector. It's more taking into account local knowledge, and we're only focusing it in this one sector because we can see it may be a difference. There is 2 other simulations, but this is using ONS data, and instead of emission coefficient WID, you'll see in the next slide it doesn't make too much difference, but again, we also make the electricity adjustment here. So what we can see here, if we just focus on the first 2, is this fact that the measurement we use does make a big difference, in particular the production-based metric, but also if you look at this ACF, so this aerial carbon footprint, you can see that if your consumption-based metric is reduced by about 10%, so you maybe be overestimating your emissions, and this is very important for policymakers. And this is this idea of, so this is we kind of want to get for this, is it's not purely academic. It's like if we take this into sort of a policymaker and say, you're overestimating your emissions, you need to do a bit better here. And what I actually measuring, and this is kind of where the conclusions come in, is we've just looked at simply one different perspective. We just took Glasgow as a case study and realised this sector is quite different from what it is nationally. So we need to take that perspective into account when we're looking at our emissions. And the size of these emissions can vary quite significantly when simple local knowledge is incorporated. We've not done anything we've not done anything complicated here. We're just taking this idea. We know that this is not how this electricity sector, and we've applied it to multi-sector modelling. And it's harked back to this idea. You can't manage what you don't measure. So are we actually measuring the right thing? So again, this is just another caveat to the research. We are using one technique. We know it's not going to be perfect, but are we actually measuring the right things? It should get people thinking about what is the most accurate data and how can it be used? So this is in the next part of this project is hopefully funding to look at what engineers, etc., can actually measure city-level emissions and see how closely they're linked to our multi-sectoral techniques, and maybe give us a better idea of what we can do. And you'll have a different range of policies and action activities, but we need to look at, well, how do these vary across activity and across space? And as a, so the Glasgow says they want the net zero carbon, but what does that actually mean? Is that a production-based method, a consumption-based metrics? We should maybe really take this into account. Is a beginning to a point where we need to specify both a production metric and a consumption metric? And that's just not for Glasgow, that's probably a national. We need to start thinking about this. And so the future, we want to model develop, we maybe want to use some real data and get to this idea. We want to look at what's impacting different households, this idea of inclusive green growth and how it's going to be impacted, and can we measure it? Can we get a better measurement? So, thank you.
Do you have any questions?
Yeah, so I sort of take your point. You want to sort of measure the right thing, and if it's not electricity generation in the area, then why should you be sort of assigning emissions based on that? But I mean, it does risk in some sense, isn't it? A bit like if you sort of monitor in sort of cities, and you sort of push electricity generation emission to places like happening globally, that aren't monitored. So in a sense, you wonder if there's sort of at least if you've got the sort of high number, then at least policymakers are motivated to do something about it. Whereas if you say, okay, well, we don't generate any electricity here, the sort of risk in a sense is that people become complacent and it gets just pushed to somewhere else. Yeah,
so that's maybe the idea as a going back to the idea, should we actually measure both production and consumption? Should these be different goals? So you maybe have on the production side, you get the active travel, whereas the consumption side, you're reducing consumption of different service goods. And this is taking an idea like, yes, it's impacting maybe China, rest of the UK. So maybe we should, it's a food for thought, should we actually start to bring that to the table instead of having we want to be net zero carbon. What does net zero carbon mean? It can be quite confusing, that net, so it's not actual zero carbon, it's you offset your emissions.
Any question? Well, I just have one regarding the how easy it would be to apply this sort of methodology to other city regions, and in terms of especially considering the data intensity. And
I think it's because you've done for Glasgow, it's not, you've got the same data available for Birmingham, you've got the same data available for London. You can do it as long as you can create a city input table. It can be applied, and there's different methods to create city input tables. So I think it could be quite easily done. Well, I don't say easily, but you've got the process there to do it. So it's just applying it using different data, but the same data sources, because most of the data we use comes from ONS. So it's publicly available.
I imagine it would be quite interesting to do this very sub-regional analysis, where the electricity come from, for those regions generating electricity, and that might have brought a completely different picture.
Yeah, I think it could be even good to compare two different regions. Maybe Birmingham and Glasgow would be good to see what results do they get if they change your electricity sector. Does it make a big difference?
Is measuring consumption really hard? If I order something online that comes from somewhere else, delivered, I just don't know even how to think about how you measure. So we had this. This is a really big issue. So we were talking about this last week, and we had an input-output focus group, a workshop, and this is becoming a real big issue because a lot of people do go on Amazon. So is there an idea if you're doing, say you're doing subnational for the UK, should there be an extra region? So instead of being Scotland, England, Northern Ireland, Wales, they 4 plus an extra region where it's just going to the US or these big companies. It's not actually itself. So I think there's a big discussion to be had here about the data for this, and it's an interesting discussion, and hopefully
if data allows, you can try and calculate it.
I think like Amazon is switching to like a UV with fleet, and well, if the electricity comes from France, I imagine the distribution of pollution will be quite different than it is what it is now.
Yeah.
I just find it a very stupid question, but it sort of hurts me on the basis of what you were saying. You showed that graph of, you know, you can have something like COVID and it's a very good way of reducing emissions. But can you use this sort of methodology to say, we have arrived at net zero, what are the different ways the economy could look like if we actually arrived at that point? So for example, this is scenario 1, this is net zero, scenario 2, this is net zero, scenario 3, this is net zero. So it's a way of getting there.
Yeah.
But what does the economy actually look like? And is one reasonably acceptable and one no way?
No, I think that would be doing the demand model and the supply model, and you can do what's happening to demand or what's happening to the labour force as well. Because when we do demand shocks, it is a lot of questions we're getting set, because I did start doing the renewables. And we're looking at like this many jobs, there is a pushback now and saying, well, where are these jobs in place from? It might not be new jobs. So I think that's right, that it can be done. I think that is very important questions here. But because I think what we try to do is, well, we did say we try to do a bit more, is the energy system model.
Yeah.
So we try to get feedback between the energy system model and then put output and see, because the energy system model, well, here's the new technologies, here's what the actual system will look like and how that feed into it.
I think that was really interesting. I was wondering if you could say a bit about what you think about future policies to address different levels of carbon ambitions between countries, like the EU seek to have the German climate club, and I don't know if there are any data implications related to those. Not something I know a great deal about, sorry, it's a silly question.
So you're talking about what kind of policies can do the best?
Yeah.
You're talking about from a national or a...
Yeah, the EU carbon border adjustment mechanism.
No, I think like that's the way probably will need to be, is like some sort of carbon tax, and I think that's what it is. But I think the design of these is really difficult when you move across border, especially if you move outside the EU, and they seem like a lot of our missions maybe not be EU based, it's China, US, rest of the world. So I think the carbon border just will be interesting, but that's within a small, yeah. But it's really, I think it needs to come down to consumer change a lot of it as well, and how well seems how do you get consumers to change is going to be really difficult, and then make a lot of pushback.
Any more questions?
What's people Glasgow City Council reaction to this work?
They've been pretty positive with it. Well, I wouldn't say pretty
It was
positive.
lower emissions than you thought you had.
Yeah.
Yeah, great.
But they do know that they may be overestimating emissions, and because I actually don't know if they actually know what their measurement times.
Yeah.
It seems to be just that seems a go-to policy at the moment. It's terrible, but because I had discussion with them, it was amount to the retrofit the tenements was insane, and if you're not getting money to do it, how are you going to do it?
So I think my line is just with hand. Matt, can mute. I'm not sure if we can hear you.
Hi, can you hear me?
Yes.
Yeah. Thanks for that presentation, Kevin. It was the second time I've seen it and I enjoyed it just as much as the first time. I think it is difficult to get Glasgow Council to react to the numbers because they're not being compared against any of the regions. I had a similar issue when I was looking at producing data sets for Cardiff. I think without the comparisons, the sort of incentives are weaker. And I think that's good that you referenced the next contribution as being a multi-regional environment account, which is obviously something that we've discussed together and I think is potentially sort of the next development of our model, as we already have the multi-regional model in City-REDI, and I think it could be an interesting contribution. I just wondered if you could talk a little bit about what you think the main sort of additional data challenges might be that we'll face going to multi-regional rather than a single regional level.
So this is going to be your trade data. It's going to be your emissions embodied in trade. So I put up a lit review. It's going to be that because, as I mentioned, it's very difficult to measure what has been traded between the different nations of the UK. Never mind you're down to ITL 1. It gets more difficult because what is the West Midlands trading with London? Can you really measure at least? And with Scotland, Northern Ireland, Wales, you have a government that's trying to measure trade. But I think the biggest issue there is trade and this idea of local units and reporting units. So you maybe have like a main business, a head office somewhere, but you have a local unit, so you don't exactly know where the material's coming from or the emissions are coming from. So I feel that that's your two difficulties. So this idea of the emissions embodied in trade and the emissions of, well, is it the head office? Should you attribute the emissions to the head office or the emissions to exactly where, say, the warehouse or an Amazon warehouse, where the Amazon warehouse is based?
And we have Simon.
Hi, Kevin. Just to, can you hear me okay? I'm just going to carry on with that theme. Yeah, nodding. Great. So that was a helpful answer because I was going to ask a similar question. My sort of follow-up question is, I assume governments are going to start putting more and more money into both the evidence base and understanding how to mitigate emissions in different contexts. My assumption also is that model will be one approach to doing this. And the question is really, if and when you ever got to a multi-regional model and ideally an international comparative model, what sort of additional insights would you get for policymakers looking to understand where more effective emissions mitigation is happening? And maybe part of the answer is to do with reducing trade flows, because the knock-on effect from trade flows in terms of scope 3 emissions is a large part of what we're looking at. Or would it give you insights into other ways, you know, assuming trade just carries on, in that some regions are doing this better than others if we look longitudinally over time? Or will it probably not get to that level of insight?
No, I think it could be, and again, that would be a big good to compare what if you did have a time series, and you can see, well, what is the different local authorities or different areas, what policies have they got difference compared to someone else? So I think it would be, and you can see, well, what policies are actually working and what aren't, if that makes sense. Because yeah, it's all good saying this will happen, but until you see the data flowing through and people's behaviour changes, it might be good for that. It will be good for that to have you an insight of what actually is happening. And as you probably know, you can do a lot of different modelling as well, different modelling of scenarios, which should help if you've got multi-regional emissions database as well.
So yeah, we have Fumi, and if you can unmute and just ask the question.
Okay. It's probably a bit sort of, local specific question. So you're looking at Glasgow City region and your kind of, local knowledge with the city, Glasgow City. But when you look at sort of the city region, it's quite kind of rural areas and quite, different kind of institutional context, Ayrshire and all of these. So I wonder what's the capacity of kind of, like local councils in terms of data processing and data production in a sort of beyond city context. So it's just like out of curiosity.
So the Glasgow City region is actually a base and it's done. So these councils are actually working together to produce this data. This is why it's kind of set up so they're aligned with each other because they've got things in common. So it should be a bit easier, hopefully, than working individually. They've all got this kind of, well, should be aligned goals. So should be trying to measure the same sort of thing.
Right. Okay, great, thank you.
Thanks.
And I think we just start on time, and thank you very much again, Kevin.
Right, thanks very much.
For everybody participating.
Thank you.